Next is we have to prove about gamma n plus 1. Then we have to prove that gamma n plus 1 equals to n gamma n. Very simple. Again we have to go for the proof of that thing. We know the formula. What is formula? Gamma n, the basic formula again, 0 to infinity e raised to minus x into x raised to n minus 1 into dx. See, whenever it is n minus 1. We know that. Now we're going for n plus 1. So n is replaced by n plus 1. This basic n replacing by n plus 1. So gamma n plus 1 will be equals to 0 to infinity e raised to minus x raised to. Now replace that n by n plus 1. N plus 1, replace n by n plus 1 and this minus 1 into dx. Then 0 to infinity e raised to minus x. Then this will be n plus 1 minus 1, this power. N plus 1 minus 1, plus 1 minus 1 cancel. So this is x raised to n into dx. Now apply LIATE rule by parts. Logarithmic, inverse, arithmetic, trigonometry, and exponential will be at the last over there. The exponential term at last, to exchange these two quantities. So we'll write down it as 0 to infinity x raised to n e raised to minus x into dx. Okay, now we have to solve this thing again. So we are solving that. What is the formula? Suppose this is first term and this is second term. First as it is, first term, second term. First as it is, integration of second minus integration of derivative of first. Dash meaning I am put a derivative. Derivative of first into integration of second. And this is whole inside this big integration. Okay, so we are applying this formula over here. First as it is, that is, first as it is x raised to n into integration of second. The integration of second is integration of e raised to minus x. First as it is integration of second minus integration of derivative of first. The d dx of x raised to n into integration of second e raised to minus x into dx, and whole it is again big integration. This is big integration, this is big integration bracket. So that is dx. Now solve it again. X raised to n integration of e raised to minus x e raised to minus x divided by minus 1 coefficient of x. Then we have to keep its limits. Limits are from 0 to infinity. 0 to infinity. This part is kept it over here. This as it is e raised to minus x integration e raised to minus x divided by minus 1. Then it is 0 to minus this integration as it is. X raised to n derivative is n into x raised to n minus 1 into e raised to minus x integration is e raised to minus x whole divided by minus 1. Then into this dx is as it is. Now we have to put out this thing, upper limit minus lower limit this side. This is remaining still simplification. The upper limit is infinity raised to n, this and this, into e raised to minus infinity minus lower limit is this 0 raised to n. Put out this lower limit into e raised to minus 0 whole divided by it was minus 1. This quantity is 0. E raised to minus infinity is 0. So 0 into anything 0. This 0 into anything is 0. So this also 0. Okay. So that we got this also 0. This also 0. 0 minus 0 0. So this whole quantity became 0. All this. Now minus this is for this thing. This minus is this minus. This minus. integration of n keep it outside, then this minus into minus will become plus x raised to n minus 1 into e raised to minus x into dx. Now this is 0, leave it, this n is as it is, integration of, I can write down it like this, e raised to this n is over here, this was 0, so leave it, integration of e raised to minus x into x raised to n minus 1 into dx. And we know what is this thing, this quantity, this is basic definition of what, this is nothing but gamma n. Whenever it is n minus 1, this is n outside, so it is n outside as it is, and this is nothing but gamma n, so this round is gamma n, so n into gamma n, hence proved.